last time we went out to sea, we looked for whales. Tonight, we're going to discover what's in our bay. The Marine Ecological Institute here in Redwood City conducts discovery voyages on their ship, the Inland Seas. We're going to join a group of 8th graders from Law and Trotter School in Menlo Park, and we're all going to go out into the deep blue bay. This is Merritt Toole, and he is a marine biologist. And now, what's going to happen when the students come on board?
When they come on board, they'll be divided into 3 teams. And one team will study the fish, put out a fish net and catch them. Another team will take a look at the geology of the water and the sediments and the chemistry. And another team will take a look at the invertebrates that they catch.
Invertebrates are what?
Animals without backbones.
Uh-huh. We're going to see those today?
Yes.
Okay, now, what happens, say, at the fishing station?
All right, a team will go back and take the otter trawl, the fish net, and put it out, and they'll drag it for about 10 minutes. And they'll all get back there and pull it in, and when it gets on board, the fish will be taken and put into a fish tank, and then they'll be identified and measured by the students using fish keys.
Now, what's the purpose about hauling in all these fish and animals from the bay?
Well, to get the kids to appreciate and the students to appreciate the fish. Most people don't have much empathy for a fish. It's a cold-blooded animal. It doesn't have fur or anything, and they really doesn't feel cuddly. So a fish is just something that
we eat.
Yeah, we eat. So a fish, if a person gets to handle a fish, pretty soon they get to feel comfortable with it, and they get to appreciate it a lot more than they do.
All right, what we have here is a large scavenger. All right.
Really a shark.
That is a real shark. That is a real shark. That's a brown smoothhound shark.
Oh, move it the other way. I don't.
All right.
Oh,
And
yeah. That's pretty good.
Reach out and touch him.
Reach out and touch him?
Rub him one way, then the other.
Wait a minute.
You have no faith in me, do you?
Well, listen, you're not holding his mouth.
Don't worry. It's a nice shark. Here is a juvenile bat ray. All right. And at the base of its tail, you can see its barb. All right. It's not the tip of the tail, as many people think. Down here at the base, all right, and that tail, or barb, secretes a toxin. It's a neurotoxin. It's quite painful and causes intense swelling. In its mouth, it's got hard, bony plates. It doesn't have any teeth. All right, these hard, bony plates crush clams and oysters. All right, so that's how it feeds. How about a live bird? How about a live bird? Who's interested in seeing a live bird? Fish lay eggs, right? Some. Not this type. This is a shiner perch. It gives birth to live young. All right. And out comes one.
Oh, my.
God. What if it's before time?
No, you can see that other one that just came out is swimming around.
Oh, my goodness.
2,
God.
3.
Wow. Oh, my goodness.
Okay, that appears it for her. It's a bottom fish. We know it's a bottom fish because it has both eyes on one side of its head.
You're
All right.
kidding. Nothing on the other side?
Nothing on the other side. All right, when this fish is first born, it has one eye on each side of its head. After about 6 to 8 weeks, this eye migrates over to here. Fish turns on its side, spends the rest of its life swimming on the bottom.
How does it... Brad,
How?
now come on.
No, really, that's true.
This sounds like science fiction. The eye moves over from one end to the other.
All right, the cell, muscles contract, cells differentiate, and it just pulls over to the other side. Well,
Okay. Now, what will the team learn that's assigned to the geology station?
Well, they'll take a sample of the water, and they'll take a look at the temperature of the water, the salinity, the amount of salt in the water, and the amount of dissolved oxygen in the water. And then they'll put over what's called a Peterson grab and take a hunk of the bottom and bring it back up and sieve through the sediments to determine what type of organisms are living in the sediments.
So the purpose of that is to see what lives in the sediment, the bottom of the bay, right?
Right.
How does that relate to me or the students?
Well, it's part of the food chain. If the organisms that live on the bottom are eaten by fish, and the fish are caught then by commercial fishermen and wind up in our supermarket. And if people have an appreciation for the organisms, again, they may not wantonly destroy them. And it's better for the estuary and better for us if we don't wantonly destroy the organisms.
you want?
You want us to get our hands in here?
Sure.
What do you think? Anything alive?
Everything's alive. Go ahead. Go for it.
Go ahead, go for it, he says. Okay, well, I'll pick up one of these squiggly things.
Now, squiggly things, please be more explicit there. What is a squiggly thing?
It looks like a dead worm.
It's the home of a worm.
Home of a worm.
Uh-huh. Now, you know, you get your hands in here, you got to realize that there's 900 million gallons of sewage dumping into the bay.
Oh, you have to tell us that, huh? Now, what's the purpose of looking at all these through microscopes and learning about all these invertebrates?
It's the base of the food chain. A lot of the tiny microscopic plants are very important in providing us with oxygen. A lot of oxygen gets made out there in the estuary, and it helps our air quality. And as the base of the food chain, the plant plankton are eaten by the animal plankton, which are in turn eaten by things like anchovy, which are eaten by striped bass, which are eaten by us. And so they are the ones that initially make the food, and it's important to us to have them there. All right, what I'm going to do now is take a little plankton, I'm going to put it on a microscope, and we'll project it on the wall. So let me go over here and grab hold of a slide and do that. What we're looking at now, the plankton. And these big guys that are right here, like this one and this one and this one, these guys are called copepods. Copepod means paddlefoot because their feet are supposed to be shaped like little oars or paddles. And copepods are very, very important in the ecology of the ocean because there's so many of them. They're very important as a food link. The copepods eat some of the phytoplankton, and then in turn they are eaten by fish like anchovies. We're having a swim through by a worm larva. Yeah, there he goes. And here comes a live copepod shooting through.
You know, I guess marine biology has become rather popular these days. Why do you think that's so?
Because the ocean is the one area we know the least about in our world. In fact, some people believe we know more about the moon than we know about our own oceans. And it's very important that we know a lot about the oceans because our lives depend very heavily on the ocean's survival. And if we succeed in polluting the entire ocean and killing off all the organisms that live in it, we're just going to kill ourselves off in the end. And if our young people have an opportunity to learn about the sea and appreciate it, then we have a much better chance of saving the sea and thereby saving ourselves.
Well, the kids are below deck getting a debriefing. We're about to dock, and I can tell you in the 4 short hours that we've been out with the Marine Ecological Institute's Discovery Voyage, we've learned a whole lot. The bay is not a bay, it's an estuary. We got to see a shark, even got to touch it. And for a land person like myself, I didn't even get sick. It's a fascinating afternoon, and you too can join. Simply call the Marine Ecological Institute here in Redwood City. This summer is the time to come. The last time we went out to sea, we looked for whales. Tonight, we're going to